Hello subscribers, here is a new video about differential equations method to homogeneous differential equations method. We have related problems also, go through it. Homogeneous differential equations. So this is our method to how to solve the differential equations by using homogeneous method we are going to see now. So if the differential equation is of the form m dx plus n dy equal to 0, then this can be done in homogeneous by using this following steps. First step, you need to convert this m dx plus n dy equal to 0 of the form dy by dx equal to f1 of x comma y divided by f2 of x comma y, where this f1 of x comma y and f2 of x comma y are homogeneous functions of same degree. So these functions must be of same degree and they must be of homogeneous. Then only you can do this homogeneous method. This is the first check you have to do in homogeneous method. For example, if you have an equation of the form, differential equation of the form x square plus 2xy dx into dx plus y square dy equal to 0, then this you have to convert in the form of dy by dx. So we will get like x square plus y square 2xy into dx equal to minus y square dy. Now dy by dx equal to this dx will send to the right hand side. So what does we get? Dy by dx equal to, and take this y square to the left hand side. So x square plus y 2xy by y square. Now we say this equation as homogeneous differential equation if we have the functions f1 of x comma y, treat this as f1 of x comma y, this as f2 of x comma y, if these two functions are of same degree or not. So here the degree of x square is 2, and here second term x into y, 1 plus 1 is 2. So here this degree is also 2. And now the whole numerator term degree is 2 because x square is 2 and 2xy xy degree is also 2, divided by, in the denominator the degree is 2. So whole equation is consisting of the same degree, that is 2. Now we can say this differential equation as a homogeneous differential equation, and we can apply this following steps. Step 2, y equal to vx, you have to substitute in place of y vx. Next, and in place of dy by dx you can substitute directly v plus x into dv by dx. So these two things you have to do in step 2. So you have to substitute y equal to vx and dy by dx equal to v plus x into dv by dx. How did we get dy by dx equal to v plus x into dv by dx? Means we need to differentiate y equal to vx with respect to x, so that you will get this. So if you differentiate y with respect to x, then you will get dy by dx, and here you are differentiating v and x with respect to x. So you can apply here uv rule. For uv rule you will get like u v dash plus v u dash, right? So u is a constant here, you need to derive only x now. So v into 1 plus again x is a constant, and derivation of v is with respect to x is dv by dx. So finally you got this one. And next, once you substitute these things, next you have to integrate it to get the required solution. So this is the process involved in solving differential equations by using homogeneous method. Let's do some example problems based on homogeneous method. The first problem here is solve x square minus y square into dx plus 2xy into dy equal to 0. How to find the solution for this differential equation we'll see. So here we are applying homogeneous differential equation. So in order to apply homogeneous method, first we need to check whether it is a homogeneous equation or not. So we have to get this in the form of dy by dx equal to f1 of x comma y by f2 of x comma y, as we have seen in step 1. So we'll apply step 1 here. X square minus y square into dx equal to, I will send this term to the right hand side. So what do we get? Minus 2xy dy. Next, so I need to get in the form of dy by dx equal to something, some function I need to get. So I will send 2xy to the left hand side and bring this dx to the right hand side. So what do we get? X square minus y square by 2xy equal to minus dy by dx. So this we can rewrite as dy by dx equal to minus, also I am sending to the left hand side, so that we will get minus x square minus y square by 2xy. So this is the functions we got here. These are the functions we got here. Dy by dx equal to, let us write this as f1 of x comma y and f2 of x comma y. Now here if you observe, the degree of this equation is 2. Whole equation you can consider as a whole function, you can consider as 2, because here the degree of x is 2 and y is also 2. Obviously this whole term degree will be 2 in the numerator. Coming to the denominator, x into y, 1 plus 1. Here we are having 1 x power 1 and y power n. If you add up the 2, you are going to get 2. So now the equation is of degree 2 and it is of homogeneous. So you can write here, given equation and mean differential equation is homogeneous. So if it is homogeneous only, then you can apply this homogeneous method. So step 1 is finished. Well, let's go for step 2. What is our step 2? We need to substitute y equal to vx and also dy by dx equal to v plus x into dv by dx. In equation 1, substitute in equation 1. So substitute here. Now on the left hand side I have dy by dx. So v plus x into dv by dx I have written here, minus x square, in place of x square nothing, so x square minus y in place of y vx we have to substitute. So vx whole square divided by 2x into vx. Next, minus of, I will put a bracket here, so x square minus v square x square by 2v x square, x into x is x square. On left hand side as usual v plus x into dv by dx you are having. Next, minus, I will take x square common here in the numerator. So what will be left over if I take x square common here? 1 will be left over, minus v square divided by 2v into x square. Now this x square and x square gets cancelled. So finally we will get v plus x into dv by dx, v plus x into dv by dx equal to minus of 1 minus v square. So also we can multiply minus to this term. We are going to get minus 1 plus v square divided by 2v, and left hand side as usual dv by dx. Now we can also send v to the right hand side. So x into dv by dx equal to minus 1 plus v square divided by 2v minus 1. Now we can take LCM in the right hand side. So first we will write left hand side term, x into dv by dx equal to, and the LCM here is 2v. So 2v minus 1 plus v square in the numerator minus v into 2v, it becomes 2v square. Next, so we can add here v square minus minus 1, actually minus 1 minus v square minus 2v square is v square divided by 2v x into dv by dx. And also you can take common here, x into dv by dx equal to minus of 1 plus v square divided by 2v. Now we can separate the terms also. Send this dx here and along with x, send this x and dx to the right hand side. Also bring this whole v term to the left hand side. So we will do it one by one clearly. X into dv equal to, first we will send dx to the right hand side. So 1 minus 1 plus v square divided by 2v into dx. Next, we bring this x here on the right hand side and send this v term to the left hand side. Now we can apply here same like method 1, variable separable method can be applied here. So variable separable method is what? Separation of x dx and y dy terms. So along with variable you need to separate the differential term. So separate now, do 2v by 1 plus v square dv equal to, we take this x to the right hand side. So what do we get? Minus 1 by both sides, or applying integration on both sides. So as 2 is a constant, you can send it outside, or you can put it here inside the integration also. 2v by 1 plus v square dv equal to minus outside integral 1 by x dx. Yesterday we have seen integral, we have a formula integral f dash of x by f of x dx equal to log f of x plus c. This formula we have seen in variable separable method. So let us check whether this formula is applicable to the left hand side integral and right hand side integral. Already everyone knows integral of 1 by x is log x. So now we will check this formula to this. So let us consider f of v equal to 1 plus v square. Now f dash of v equal to what? Differentiation of 1 is 0 and differentiation of v square is 2v. So f dash of v equal to 2v we have got. Integral 2v by 1 plus v square dv equal to, you can assume this as f of v, and here we got f dash of v equal to 2v, which means here the numerator term and f dash of v are both are equal. Directly we can apply this formula. So integral this becomes now log f of v, that means log 1 plus v square plus c. Now we can apply, substitute here in the equation 2. Now equation 2 becomes what? Becomes comma log of left hand side totally becomes log of 1 plus v square equal to, plus you can consider, otherwise you can directly write after integrating this term also, minus log x, because integration of 1 by x is log x, plus we can write here constant after integration, that is mandatory. So you can write like c, otherwise log c also you can write. So log c. Now log of 1 plus v square plus I will bring this log x to the right hand side. So it becomes log of 1 plus v square plus log x equal to log c. Now log a plus log b equal to log ab. So log of 1 plus v square into x equal to log c. Next step is to apply antilog on both sides. So this becomes now x into 1 plus v square equal to c. By this our problem is almost completed. Now a last step is there. So we have assumed in equation, after equation 1, y equal to vx, right? We have assumed here y equal to vx. Now our question is in the form of x and y variables. So obviously we need to get the solution also in x, y and constants also if possible. So definitely we need to get the solution in x and y terms only, and no other variables are allowed in the solution. So we got the solution in terms of x and v. Now we need to convert this v in the form of y and x both. That's why we need to convert this y equal to vx in the form of v equal to something. Now this becomes v equal to, send this x and x to the left hand side. So this becomes v equal to y by x. So wherever v is there, after getting the solution, we need to replace it with y by x. Now substitute here v equal to y by x. So this becomes x into 1 plus v square, that means y square by x square equal to c. That implies, we will do it in another page. So we can take LCM here, x square plus y square divided by x square equal to c. This x and this x gets cancelled. So you will be left over with x square plus y square by x equal to c. And till here your solution is completed. If you want to solve further, you can extend this x square plus y square equal to, send this x to the right hand side. So this becomes cx. This is the required solution of the given differential equation. Next problem, solve dy by dx equal to y by x plus tan y by x. So how to solve this type of problems? First we need to check whether it is a homogeneous differential equation or not. Then we need to apply the homogeneous method. So first step is dy by dx equal to f1 of x comma y by f2 of x comma y. So this is already in the form of dy by dx equal to some function. So next we need to identify the degree, whether it is homogeneous or not. The whole equation should consist of a same degree. Now the y term degree of y term is 1, x term is also 1. Now this whole y by x degree is 1 and tan y by x degree is also 1. The complete equation degree is also 1. Therefore, we can write that given differential equation is a homogeneous differential equation. So our step 1 is completed. We have checked whether it is a homogeneous differential equation or not. Take this as equation 1. Next, we'll go for step 2. In step 2, we need to substitute y equal to vx and also dy by dx equal to v plus x into dv by dx. So these are the two things we are going to do in we are going to substitute in equation 1. So on the left hand side we have dy by dx, substitute that there. So v plus x into dv by dx, substitute in equation 1, equal to, here we have y. So what is our y? Vx divided by x. For x we don't have any substitution, let it be like that. Tan plus tan y by x, in place of y again vx divided by x. So we have any cancellations? If we have any cancellation we can cancel. Vx by x, x and x gets cancelled. Here also x and x cancel, will be left over with tan v. So finally we got v plus tan v on the right hand side. Left hand side v plus x into dv by dx. Here v and v gets cancelled. Otherwise if you want to bring this v to the right hand side, we will get v minus v equal to 0. So otherwise or else you can cancel like this. Next, x into dv by dx equal to tan v. Finally we got this tan v. Send this dx to the right hand side. So we will get x into dv equal to tan v into dx. But now we can apply the variable separable method. First for that you need to separate these terms x dx and v dv terms. I will bring this tan v to the left hand side and take this x to the right hand side. So what does it become? 1 by tan v dv equal to 1 by x into dx. So separation of these terms are finished. Next step is to apply integration on both sides. Apply integration. Our third step is apply integration on both sides. So integral 1 by tan v dv equal to integral 1 by x dx. So 1 by tan v is, you can directly write cot v dv equal to integral 1 by x. Now integration of cot v is log sin x, log sin v equal to, and integration of 1 by x is log x plus one constant we need to write, as everything we got in terms of log. So our constant also let us write in log terms only. So log c. Take this x to the left hand side. So what does you get? Log sin v minus log x equal to log c. So log a minus log b is log a by b. Sin v by x equal to log c. Next our step is to eliminate log. So apply antilog on both sides, so that finally you get sin v by x. Here I am doing here itself. So sin v equal to c. But this is our final answer. We cannot say this as final answer because our question is in the form of x and y terms, as we have discussed in first problem. Here also our solution must be in the form of x and y only. We should not get in terms of v and x. So we need to replace v with what? Y by x. So substitute v equal to y by x. Now sin y by x equal to c. This is our final solution of this given differential equation. Hope you like the video. Please subscribe, like and share the video. Thank you for watching.